One of the biggest questions that humans have faced is, where did everything come from? However, we may be close to getting the answer thanks to a new theory that some people may find scary. The Big Bang may be wrong and we live inside a black hole. Come with me on this inspiring journey. What is the reasoning behind this statement? What does it mean that we live inside a black hole? Inside a black hole, space and time are so distorted that direction is reversed. If someone enters a black hole, they will be inexorably pulled towards its center, regardless of how fast they are moving as they approach the center. Their feet would start moving faster than their head, and eventually, the person would be stretched like spaghetti and torn apart. Our universe is so large that it seems like nothing can exist outside of it. Help us grow and reach more people. If you like our content, please don't forget to value my hours of research and production. Subscribe to the channel, like the video, and share it with your friends on social media. Now, physicists are beginning to think that our universe may exist inside a black hole. This may sound strange, but in fact, it could be the best explanation of how the universe began 13 billion years ago. This theory has been explored over the past few decades. To create a black hole on Earth, it would be necessary to pack everything into a volume the size of an olive. Most of the black holes we know are much larger than that, with masses billions of times greater than the Sun and volumes that span our entire solar system. As for the observable universe, we know it is expanding, but not into nothingness. In fact, space itself is expanding due to the particular way the universe expanded shortly after its birth. We also know that there are parts of the universe that are currently unobservable to us, as they are outside the so-called observable universe. There are parts of the universe that are so distant that we cannot see them. The observable universe is defined as a sphere around us, composed of all things that have had a chance to send a light signal that we could receive. Furthermore, we have no idea how large the entire universe is. Currently, the observable universe has a diameter of about 93 billion light-years. But we have no idea about the total size of the universe. It could be infinite or it could be something smaller, and we do not know. If we wanted to create a black hole that encompassed the entire observable universe, we would have to place it in a sphere slightly larger than the current observable universe in which we live. It is possible that our observable universe is inside a massive black hole. Black holes are more than just astrophysical curiosities. The event horizon of a black hole becomes a barrier, a boundary that is always distant and can never be reached. This point in space is a region that you could never reach and that is always moving away from you, a horizon. But think about what this means for us here on Earth. If we look out into space, there is a very, very distant horizon beyond which we cannot see. We know there are things there, but we can never see them, and no matter how fast we travel, we will never be able to reach them. This is remarkably similar to what we would experience inside a black hole. It has been found that the mathematics inside a black hole is almost identical to the mathematics outside the black hole. This is really what is happening mathematically. The black hole is large enough for you to be comfortable, but it would still be a one-way trip. Once you cross the event horizon, there is no way back. It also makes sense that Albert Einstein predicted the existence of black holes in 1916 with his general theory of relativity. Over the past 100 years, scientists have repeatedly tested Einstein's general theory of relativity, trying to find situations or circumstances for each one. The image of a black hole was captured in 2019 at the center of the supergiant elliptical galaxy Messier 87, which is in the constellation Virgo. You are looking at a black hole that is essentially the size of our entire solar system, 500 billion kilometers away from us, but at the same time was large enough, measuring 100 billion kilometers in diameter and has 6.5 billion times the mass of our Sun. The problems about black holes that have not yet been resolved and intrigue us are, first, the nature of their singularity. What really happens when the curvature of space and time diverges inside a black hole is that a channel, a path to another universe, exists an object there where matter accumulates according to Einstein's gravity. It accumulates a singularity and thus a paradox arises. In order to discover the world, we need to push boundaries, and the best places to push boundaries are under extreme circumstances in extreme environments. And the most extreme environments we know in the universe are black holes, because they represent places where space and time themselves perforate pathological behavior that leads to paradoxes within physics. One of the strange characteristics of general relativity is its ability to warp space and time to the point where time and space can switch places before it's where the signature of the spacetime metric changes. In general relativity, the metric is what tells us how space and time act and what distances mean at a given point. Intense concentrations of matter distort space and time so that the metric changes what space and time mean for different observers. The Big Bang Theory suggests that, at least for certain forms of singularities, once matter reaches a singularity, it enters a new universe where time at the singularity is the starting point of that universe. This theory is based on the fact that the universe appears to be expanding. If the universe is expanding, then at some point in the past, it must have been much smaller. The universe tends towards disorder. That's how it works. Everything becomes more disorderly over time. However, the Big Bang was an exceptionally ordered thing, which is strange, because the universe could have gone in many different directions. The theory of quantum fluctuation suggests that the Big Bang arose from a spontaneous fluctuation and came into being in a highly ordered state. Since then, the universe has been getting more and more disorderly. Disorder is a measure of the probability of something being created spontaneously. The more disorderly something is, the more likely it is to be created. Since the universe today is less ordered than it was in the past, it is more likely to have arisen spontaneously. This means that the entire universe, including everything we can see, is more likely to have arisen from quantum fluctuation than from the Big Bang. If the theory of quantum fluctuation is true, it means that our universe began as a small particle of matter inside a black hole. Over time, the black hole evaporated due to Hawking radiation and our universe expanded to its current size. This theory explains many mysteries about our universe, such as why it is filled with so much dark energy, and also provides a possible explanation for how our universe came to be. The idea that our universe may be inside a black hole is interesting and is something that scientists are still exploring. Although we do not know for sure if this is the case, it is definitely something worth considering. If our universe is really inside a black hole, it would explain a lot about how things work and how we experience life. It would also mean that there is much more to explore, which is always exciting. I hope you enjoyed the adventure. See you in the next video.